So good morning. We will look today at lab 11. I've already put down the circuit at the base, and I wanted to add some things that you haven't seen yet. So I have here the battery, but that's not the one. I want to show you how to get to it. That's not the one I used. So battery. There are a few here, the cell and the battery that we can use. I actually, when I did the lab earlier, used the cell and not the multi-cell battery. For the lab that we are doing, it's no problem to use one or the other. So we're going to put it here. We're going to connect it. That doesn't look nice, but we can fix that, right? We can push it a little down and maybe highlight the whole thing and bring it just once down. That doesn't like it. It's okay. We can, oh, using the selection mode, we can select it and bring it in a little bit, and that looks better. So here we have added the battery, and it's at 1.5 volts. Usually by default, it's at 5 volts, but I think that maybe because I've been using it a lot, it went to the last value that I used. And we can start the simulation, but if we don't have any measuring tools, we're not going to see anything. So for the first part of the lab, you need to measure the voltage VCE, right? Or V out, which is at VC. So actually we need to measure VC. So we're going to take a DC voltmeter and we're going to put it, and this you've done before. This should be a walk in the park for you, right here. And when we play, we can see the values and we can take them down. Of course, the lab tells you to go from 0 volts to 5 volts in steps of 1 volt. You have to stop again. You have to stop the simulation each time to change the value of the voltage that you put here. So with 5 volts, what do you get as VC? So V from the C point all the way to ground, that's VC. You're getting 0.04. Oh, I just gave you the answer for one of them. Moving forward to the next parts. You have some explanation to do, and you have your currents in part 2 that you have to measure. So for the currents, you could go with the DC ammeter, but I like the probes better for this one. And also, it will be a good time to show you something particular about the probes. So we're going to take a probe and we're going to put it over here because we need to take the current of IB. And we're going to take another probe and we're going to put it over here because we want IC. So let's zoom in a little bit. Let's name those the way we should, just to see it correctly. IB and IC. And we zoom out a little bit and we start the simulation. And it gives us voltage because I took the wrong probe. Okay, so let's undo that. Let's stop the simulation. Let's delete those. We want the current probes. We want to put IB and say OK, and IC and say OK, right? And we start the simulation. And oh my God, we get an error. I don't know if you had this problem before, but this is something I've discovered. It's a little funny that it does that, but the probe here, IC, it's asking for the current going into the wire this way. It's a little weird to say that, but you have to align this image here, the circle with the arrow, with the current that you want to measure. If it is perpendicular to the line, it will not work. So you want to highlight it, and you either turn it by clicking the right button, editing, and rotating clockwise. So we'll do it that way. That's the easiest way. So the current is going downwards, and we start the simulation again. And everything is great, except that you can't see it very well because it's going over the Q1. So we can stop that, and we can do two things. We can just actually move these. Don't double click, just drag it out. Unfortunately, there's nothing you can move on this probe so it doesn't show the current there. It's just the way the simulation is done. So here, if we started, we can see it correctly, 0.045 and 0.028 amps. So you convert that into milliamps, please, when you put it in your lab report. Always engineering notation, please. Then you have some calculations, and then we go to part 3. And in part 3, so let me stop the simulation. In part 3, what we want to do is, instead of this voltmeter, we want to put a load, which will be Dell or lead. So we're going to go here again to our parts. And we're going to go here. Now we're just going to type lead. And we're going to see we have a lot of LEDs. And I'm going to ask you to go and type active on top of it. And we're going to get a whole bunch of active LEDs. So active means that you will see something. There will be an action. So even though the simulation of these makes your circuit act like a digital circuit, it will still work the way we want. So let's grab a few of these, doesn't matter how many. You just double click on them and they will appear. If I move this box, they will appear in the devices, right? And then we say, okay. And then we have a whole bunch of devices here. And we click on one. We're going to put it right here, and we're going to connect it. So there is a reason to my madness why I asked you to add so many here. You'll see in a moment. So let's try to play. And right now we're not getting anything. The LED is off. So we need to change the value of the battery in order to get the LED to light up. So as you see, it lit up, but the blue one is not very bright. So sometimes it's a little bit harder, especially if you have more than one LED, it will be harder to see. So I think the yellow, oh, I didn't take the yellow one. So let's try a pink. So you want to click, you want to put it on top, click down and replace the component. This is beautiful. It replaced the component for us directly. We didn't need to delete it and put it back in. So we have a beautiful pink LED that turned on. Okay, so you have this going. Now, I think you're good for part 3 and all the questions of part 3. One last thing I wanted to teach you is this. As you stop the simulation and you say to yourself, well, I have all these parts that I'm not using, and maybe you tried and maybe you played around and you have lots of parts and you want to clean it up. So you have here tidy, and it's going to say it will remove unused devices from the selector. And then you will be left with only the parts that you have used. So this is nice because it allows you to have a cleaner working space. So good luck with your lab. I hope you enjoy it, and let me know if there's anything that you need. Bye, guys.